Hey everybody, in this video we are going to solve 2x2 systems of equations using the elimination method. Our first step is going to be set up equations to cancel one variable. In number 1 here, that step is actually already done because positive y and negative y are exact opposites of each other. So that step really means make one of the variables exact opposites of each other, and that's already there. So we can move on to step 2. Cancel one variable and solve for the other. So what I can do is combine these two lines just by adding according to the signs. X plus 2x is 3x. Negative y and positive y is 0. So those cancel each other out. 5 plus 7 is 12. So if I divide by 3, I get x is 4. So these two lines, when I graph them, they would intersect at a point where the x value is 4, and now we need to solve for y. So we'll plug in our variable that we have already found. We'll plug in x to one of these two equations and solve for the remaining variable, which is y. It does not matter which equation I use, but this top one here looks easier. So I'll plug x in there. 4 plus y equals 5. Minus 4 on both sides, and I get y equals 1. So these two lines should intersect at 4, 1. The last step is to check. If I plug x and y in for x and y in both equations, then I will know if my answer is correct or not. But it has to be both equations. We might substitute into the top equation and see that it checks out, but that really just means this point is on this line. But it might not be on this line, and we need it to be on both because the solution will be the intersection of the two lines. So if I plug in x and y, that's 4 plus 1 equals 5. That checks out. 2 times 4 is 8, minus 1 is 7. That checks out, so I know this solution is correct. On number 2, we are not set up for elimination just yet, but I think the easiest way to get there is to take this top equation and multiply it by 5. That will give me a positive 5y, which will be exactly the opposite as from negative 5y. So I'm going to bring this down here, multiplying by 5, so that's 5x plus 5y equals 30. A common mistake is not to multiply this last part, so we need to make sure it gets distributed everywhere. So now I can combine these two lines. 2x and 5x makes 7x. Negative 5y and positive 5y is 0, so they cancel. Negative 16 plus 30 is positive 14. And if I divide by 7, I get x equals 2. So this intersection should take place 2 to the right. And then I think the top equation is going to be the easier one to plug into. So 2 plus y equals 6. Subtract the 2, y is 4. So the intersection should take place at 2, 4. Now let's check that. 2 plus 4 equals 6. Check. 2 times 2 is 4, minus 5 times 4, which is 20. So that's 4 minus 20. That is negative 16. So this point works for both equations, so that is the solution. And on number 3, we can choose x or y. I don't know that one is going to be much easier than the other, so if we choose to eliminate the x's, the easiest way to recognize is to multiply this top one by 6 and this bottom one by 4, but that won't make them opposites. That will make them exactly the same. Okay, so they'll both be 24 this way. We could just change one of them to a negative. Let's just say we change that bottom one to a negative. Doesn't matter which. Okay, now it doesn't have to be 6 and 4 because I think if I did the top one by 3 and the bottom one by 2, we would get 12s. Okay, but sometimes we don't recognize that lowest common multiple So we just go with use that 6, use that 4, and make one of them negative so they have opposite signs. Okay, so when I distribute this 6, I get 24x minus 18y equals negative 12. And when I distribute this negative 4, I get negative 24x plus 28y equals negative 28. And these will cancel. Negative 18 plus 28 is 10, so 10y equals negative 12 minus 28 is negative 40. So that's 10y equals negative 40. And divide by 10, and I get y equals negative 4. So this intersection should happen at some x value with a y value of negative 4. I think the top would be easier to plug into just because it's smaller numbers. 4x minus 3 times negative 4 equals negative 2. So 4x, and then negative 3 times negative 4 is 12. And if I subtract that 12, I get 4x equals negative 14, and then divide by 4. Okay, now this is not going to be a whole number, so I can just simplify that fraction. It's going to be negative, and 2 goes into both of these 7 times and 2 times, so negative 7 halves is my x value. Okay, now, of course, I should check this. And for this one, I will pull out a calculator just to make it a little bit easier. So 4 times negative 7 halves minus 3 times negative 4 is negative 2, just like it's supposed to be. So it worked for the first line. 6 times negative 7 halves minus 7 times negative 4 is 7, just like it's supposed to be. So this point checks out in both equations. Number 4, if I multiply by negative 4 up here and bring it down here, I'm going to eliminate the x's. So I get negative 4x plus 8y equals 24. And the x's cancel, and look at this, the y's also cancel. And I get 0 remaining on this left side equals 32. But we're smart enough to know that 0 does not equal 32. So I got a false statement here. If I cancel the x's and the y's and I get something that is false, that means these are parallel lines. And the solution is the point of intersection. Parallel lines do not intersect, so there is no solution. Okay, here I will multiply by negative 5 and bring it down here and get negative 25x, so the x's will eliminate. Positive 20y, so the y's will eliminate. And negative 5 times negative 17 is 85. Oh, and those are going to eliminate also. So I'm going to have 0 equals 0. Now that is a true statement. That means that these two equations are actually two different equations for the same line, which means every point along the line is a point of intersection of these two lines. And there's an infinite number of points along the line, so there are infinite solutions to this set of equations.